Hi everyone, this is the essential questions for this lesson. It's 15.4 and 15.5. We're getting into perpendicular bisectors and angle bisectors of a triangle in particular. So our essential questions, how can we use the perpendicular bisector to find the point that is equidistant from all the sides of the vertices of a triangle? How can you use angle bisectors to find the point that is equidistant from all the sides of the triangle? Okay. So here are some definitions that we have to cover first. Okay. Circumscribed is basically this circle, circle C, and we label it from the center point. That's the circle C. A circle that contains all the vertices of the polygon, okay, is called a circumscribed about the polygon. So circle C is circumscribed about the polygon when all the points of the polygon, or in this case, the triangle, right, is on the circle. That's what circumscribed means, okay? So if you read here, circle C is called the circumcircle of the triangle XYZ. The center point is called the circumcenter. All right. And this point is key as well. And you'll figure out in a little bit. Okay. So the circumcenter theorem, there's a theorem that correlates to the circumcenter. If you draw the perpendicular, or if you get the perpendicular bisectors of all the sides of the triangle, so you see triangle ABC here, right? And if we get all the perpendicular bisectors, meaning this P and this point here, I want to label it D, is the perpendicular bisector of AC because it's perpendicular to AC and it also bisects it. Okay, PE, I'm going to label it, is also the perpendicular bisector, whereas they're perpendicular and then these sides are equal. And then PF is also the perpendicular bisector because it's perpendicular and all of these sides are equal, right? So we got three perpendicular bisectors, and right where they meet, let me erase all of this, and right where they meet at point P, right? They meet, this guy meets at point P, oops. This perpendicular bisector, this perpendicular bisector, and this perpendicular bisector all meet at point P. Okay, if we have that, then we know that PA is congruent to PB and is congruent to PC. Okay? So that point going to all the points of the triangle are congruent. All right? Okay, so this is my next slide. And it's an example of using that. Okay? So KZ, LZ, so this KZ, LZ, and MZ are all perpendicular bisectors. So they're given that they're already perpendicular. So I'm just going to draw little tick marks to showcase that they're all equal bisectors, right? So MZ, for example, bisects GJ. Okay, and so on and so forth. Use the given information. So here we have example 1. Okay. ZM is 7. So I'm going to erase all of this so that it doesn't get too messy. So this is example 1. ZM is 7. ZJ is 25. HK is 20. Right? We have that. And we know the perpendicular bisectors. So ZH, we got to figure out. I'm going to label it X. HG, we got to figure out. I'm going to label this Y. Okay. So because ZK is a perpendicular bisector, if this is 20, if HK is 20, then I know GK is also 20. Right? So the whole thing, HG is going to equal 40 because 20 plus 20 is 40. All right. And then ZH, my X. So if we have the perpendicular bisector, right, meeting, they all meet at point Z, right? They all meet here, right, at point Z. Yeah. Then I know that this guy is congruent to this guy and is congruent to this guy. Okay, they're all congruent to each other, right? Based off of that theorem that we just went over. So if ZJ is 25, ZH is also going to equal 25. Simple? Yeah. Simple, simple, simple. If you guys in these two sections, if you guys think it's congruent, most likely it is. Okay. All right. So erasing this and going on to example 2. ZH is 85. Ooh, that's a big number. MZ is 13. HG, this whole thing, is 136. Okay, we're given that. We got to find KG. We got to find this value, X. And then ZJ, Y. Okay. ZJ is the simplest to find, right? The Y value. Because again, if Z is the perpendicular bisector where all the perpendicular bisectors meet, then going to the points of the triangle, they're all equal, right? So if ZH is 85, Y is also 85. Okay. And then we got to find KG, right? I know that this is equal to that, right? So I have 2x, right? So if I just divide 136 by 2, what is 136 divided by 2? That's 6, 12, 1, 6, that's 18, right? 86 or 68. This is 68, and this is 68. Okay? So KG is equal to 68. All right? Cool. Simple so far? That's your first big theorem, okay? The circumcenter theorem. All right? So here's 2 other theorems based off of the angles. If a point is on the bisector of an angle, so they're talking about, if you guys see this picture here, I'm on this picture here. If point C is on the angle bisector. You guys see these little tick marks here and here? Yeah, that means that they're equal. Okay, these angles are equal, and point C is on the bisector of the angle. Then it is equidistant from the sides of the angle. So from that point, if you find out the perpendicular segment, you find the perpendicular segment of the angle itself, then those guys are congruent. Okay? That makes sense? If we have a point on the angle bisector, right? The bisector of an angle, then these guys are going to be congruent. And this is just the converse. So if we know that they are congruent, then I know they're going to be equal to each other. Okay? Okay, let's see an example in this. So here, we have to figure out what QS is, right? QS is right here. I know S is on the angle bisector because they are congruent to each other, right? I know that SQ is the perpendicular to PQ, and I know SR is perpendicular to PR, right? And that's the angle itself. So this X is equal to 14.7. Again, if you think they're equal, they're pretty much going to be equal. All right. So in this case, I have to figure out this whole angle here. I'm going to label that X degrees. Okay. And I'm given that KJM, this angle here is 29 degrees. Right? But I also know that they're perpendicular and they're both equal to each other because they're both 62. So I know that these two angles is going to be the bisector, right? That JK bisects this angle LJM. So if this is 29, then this is also 29 degrees, making the whole thing my X degrees, whole thing 58 degrees. Okay, pretty simple. Yeah. All right. So moving on. This is the in-center theorem. Okay. The angle bisectors of a triangle. So all of these are bisectors, right? BP is a bisector, AP is a bisector, CP is a bisector of that angle. And if they all intersect at one point, point P, then the perpendicular sides are going to be equal to each other. All right? That's the theorem that we're going to work with right now. So here, QX, where's QX? QX and RX are angle bisectors, right? So then I know, oops. So then I know that they're equal to each other and they're equal to each other, right? They're angle bisectors and they meet at X. Find the measure of each. Okay. So I gotta figure out this guy here. I'm gonna label that X degrees. I have to figure out PQX. So I gotta figure out one of these guys, right? I'm gonna label that Y degrees. Oh, that's not degrees. X is not degrees. Right, that's just the side length. So it's not degrees. Okay. So let's start off with what I do know. Okay. Because right now I don't know anything. Right. I know that this is 19.2. XY is 19.2. If XY is 19.2, then X to PQ, this guy here, is going to be 19.2 as well. Okay, because of that theorem. Okay. Now let me erase all of this and focus on this is 19.2, just so that you guys can have the answer. This guy. Okay. So they're all angle bisectors. So if this is 12, this is also 12, right? Degrees. So this whole angle here is 24 degrees. Oops. Correct? This is 24 degrees, right? The whole angle. I know this triangle PQR, this angle P is 52 degrees, correct? So how do I find PQX? Half of PQR. Well, this guy is going to be, I'm going to add 52 with 24. That'll get me 76, right? And with this number, I'm going to subtract 180, which gives me 104 degrees, right? So why did I do this? The 104 degrees, that is this angle here. That whole thing is 104 degrees because 52 degrees plus angle Q, angle PQR, and angle QRP, this angle here, they're all going to make a triangle, right? And if they make a triangle, they equal 180, correct? So I subtracted 76. So I need 104 degrees more because I know 24 and 52 are the two angles. So this is 104 degrees, but half of that is going to be 52 degrees. So 52 degrees is your answer. That make sense? Yeah. Questions on this? And that's the lesson for today, class, on perpendicular bisectors and angle bisectors. Okay? So hopefully all of this was coherent. And I'll see you guys on the next one.